When we talk about dengue fever, I am very sure that everyone is familiar with that disease. As we know, millions of cases of dengue infections occur worldwide each year. But the issue is, where does the dengue fever come from? For our information, dengue fever is a tropical disease caused by a virus carried by mosquitoes. Like other viruses, dengue virus is microscopic structure that can only replicate inside a host organism. The dengue virus are members of genus Flavivirus in the family Flaviviridae. In 1943, Ren Kimura and Susumu Hotta first isolated the dengue virus. These two scientists were studying blood samples of patients taken during the 1943 dengue epidemics in Nagasaki, Japan. A year later, Albert B. Sabin and Walter Schlesinger independently isolated the dengue virus. Both pairs of scientists had isolated the virus now referred to as dengue virus 1, which is DEN1. Dengue infections are caused by 4 closely related viruses named DEN1, DEN2, DEN3, and DEN4. These 4 viruses are called serotypes because each has different interactions with the antibodies in human blood serum. The 4 dengue viruses are similar. They share approximately 65% of their genomes, but even within a serotypes, there is some genetic variation. The dengue virus genome is a single strand of RNA. It is referred to as positive sense RNA because it can directly translate it into proteins. The viral genome encodes 10 genes. The genome is translated as a single long polypeptide and then cut into 10 proteins. The structure of the dengue virus is roughly spherical with a diameter of approximately 50 nanometer. The core of the virus is the nucleocapsid, a structure that is made of the viral genome along with C proteins. The nucleocapsid is surrounded by a membrane called the viral envelope, a lipid bilayer that is taken from the host. Embedded in the viral envelope are 100 active copies of the E and M proteins that span through the lipid bilayer. These proteins form a protective outer layer that controls the entry of the virus into human cells.
How does the virus behave when it enters the human body? The dengue viral replication process begins when the virus attaches to a human skin cell. Dengue virus is an RNA virus that is covered with envelope protein surrounded by a lipid bilayer envelope. Inside the envelope is a capsid shell that contains the virus RNA genome. Immune cells are targeted by the dengue virus. There are 2 cell surface receptor molecules important in dengue infection. The cognate receptor is involved in normal infections and the Fc receptor is involved in a phenomenon called antibody-dependent enhancement. The virus envelope protein binds to the cognate receptor and triggers a cellular process called receptor-mediated endocytosis. The virus is internalized in a bubble-like structure called the endosome. When endosomes form, proton pumps lower the pH of the interior. The virus responds to the lowered pH by changing the conformations of the envelope protein to form spike-like structure. The tips of the spikes are hydrophobic, which allow germs to penetrate the endosome's membrane. They bend until the endosome's membrane and the virus membrane fuse together and release the capsid into the cytoplasm. The capsid breaks apart and releases the viral RNA. The viral RNA travels to the rough endoplasmic reticulum. It is a positive sense strand and can be directly translated into protein. The ends of the RNA form structures that bind to translation initiation protein. The complex attaches to the ribosome to initiate translation. The whole viral genome is translated as a single long polyprotein chain. The capsid protein is on the cytoplasm side of the endoplasmic reticulum. The envelope protein and the pre-membrane protein are in the lumen site and are activated by the host peptidase enzyme. In the cytoplasm, one of the viral protein, a protease enzyme, activates all the other protein in a polyprotein chain. This protein aggregate to form the RNA replication complex. The viral RNA is synthesized in multiple steps. First, the end of the viral RNA fold up and the RNA forms a circle. The RNA then attached to the replication complex to start the first round of synthesis. Using the virus positive sense RNA as the template, a negative sense copy is made. The pair of RNA strands form a double helix. The RNA then becomes a circle again. The negative sense strand acts as a template to make a positive sense strand. Many copies of the positive sense are made by repeated cycles of RNA synthesis. Some of these strands are translated to make more viral protein. Eventually, enough proteins are made to assemble new viruses. The envelope proteins aggregate in the lumen of the endoplasmic reticulum, and the capsid protein aggregate on the cytoplasmic site. A viral RNA binds to the capsid protein and is packaged into a new virus particle as it buds off the endoplasmic reticulum. The virus is still immature. Its pre-membrane protein cover the tips of the envelope protein to prevent premature fusion back into the cell. The virus buds off and travels through the Golgi apparatus and continues toward the cell surface. Before reaching the surface, the pre-membrane protein is processed and the virus becomes mature. New dengue viruses are released from the cell ready to infect other cells.
Dengue is a severe flu-like illness that affects infants, young children and adults but seldom causes death. Symptoms usually last for 2 until 7 days after an incubation period of 4 to 10 days after the bite from an infected mosquito. The World Health Organization classified dengue into 2 major categories, which is dengue with or without warning sign and severe dengue. The subclassification of dengue with or without warning sign is designed to help health practitioners triage patients for hospital admission, ensuring close observation and to minimize the risk of developing the more severe dengue. Dengue should be suspected when a high fever, which is 40 degrees Celsius, is accompanied by 2 of the following symptoms during the febrile phase, such as severe headache, pain behind the eyes, muscle and joint pains, nausea, vomiting, swollen gland, and rash. Most people recover within a week or so. In some cases, symptoms worsen and can become life-threatening. This is called severe dengue, dengue hemorrhagic fever, or dengue shock syndrome. Severe dengue happens when your blood vessels become damaged and leaky, and the number of clot-forming cell platelets in your bloodstream drops. This can lead to shock, internal bleeding, organ failure, and even death. Women who get dengue fever during pregnancy may be able to spread the virus to the baby during childbirth. Additionally, babies of women who get dengue fever during pregnancy have a higher risk of preterm birth, low birth weight, or fetal distress. Warning signs of severe dengue fever, which is a life-threatening emergency, can develop quickly. The warning signs usually begin the first day or 2 after your fever goes away and may include severe stomach pain, persistent vomiting, bleeding from your gum or nose, blood in your urine, stool or vomit, bleeding under the skin which might look like bruising, difficult or rapid breathing, fatigue, irritability or restlessness. The incidence of dengue has grown dramatically around the world in recent decades. A vast majority of cases are asymptomatic or mild and self-managed, and hence the actual number of dengue cases are underreported. Many cases are also misdiagnosed as other febrile illnesses. One modeling estimate indicates 390 million dengue virus infections per year, of which 96 million manifest clinically with any severity of disease. Another study on the prevalence of dengue estimates that 3.9 billion people are at risk of infection with dengue virus. Despite a risk of infection existing in 129 countries. 70% of the actual burden is in Asia. The number of dengue cases reported to WHO increased over 8-fold over the last 2 decades, from 505,430 cases in 2000 to over 2.5 million in 2010 and 5.2 million in 2019. Reported deaths between year 2000 and 2015 increased from 960 to 4,032. This alarming increase in case number is partly explained by a change in national practice to record and report dengue to the Ministry of Health and to the WHO. But it also represents government recognition of the burden and therefore the preparedness to report dengue disease burden. Therefore, although the full global burden of the disease is uncertain, this observed growth only brings us closer to a more accurate estimate of the full extent of the burden.
Nangyari doon, I wasn't eating for about 2-3 days. Parang wala akong panlasa. My fever was low, kaya ako rin-rush sa hospital. Nagkaroon ako rashes sa stomach. Medyong binabantayan nila kasi dito sa second strain, second attack. So, second attack, usually mag-hemorrhage ka eh. Alam saan nagaling outbreak, was it a virus? Kasi dengue, hindi naman masyadong kilala at the time. So, kaya lang nalaman ng dengue when my classmate died. Nangyari was, nung rin sa hospital kasi, sabi ng classmate ko daw, parang, "Mommy, I cannot see anymore." Tapos, ang kwento ng doctor, tsaka ng mommy, parang may lumalabas na ng blood sa eye sockets, tsaka sa nose, tsaka sa mouth, parang nag-hemorrhage na. Tapos, kinonfirm nga that there was a disease that came from another tropical country from a mosquito, which happens to be dengue. Roughly less than a month, nagkaroon ako ng fever. Without being tested yet, on the second day ng lagnat ko, na-test na ako, pero wala pang results. Tinakbo ka agad ako sa hospital. Kasi tinanong ng doctor sa mami ko, "Are you comfortable with this fever or you don't feel right?" Sabi ng doctor, kasi ako, I don't feel right about it. Sabi niya sa mami ko, "Do you feel right?" Sabi ng mami ko, "No." Sabi ko, "I'm a little scared about this. Sige, let's put him in the hospital until such time na may resulta. At least we're on the safe side." So, the third day na hospital na ako, nakaswero ako. Fever ko was low grade. Okay naman, nothing serious. It's just that wala kang gana kumain. Dumating resulta, kwento sa akin, i-interpret ng doctor to make an accurate finding. Di ba kasi ngayon, dengue confirmed. Nung panahon na hindi ganun eh. So, based on that, may dengue nga ako. And on that 7th day, nakauwi na rin ako. That was the first. The second was 1987. This time around, kaya ako rin sa hospital, nagkaroon ako rashes sa stomach. Medyong binabantayan nila kasi dito sa second attack. So, second attack, usually mag-hemorrhage ka eh. Pero when I was starting to have patches na kasi, naiswero na ako kaagad. Di ba kasi ang dengue, lumalapot yung blood. So, it thickens until magsisip siya out of your body, tapos nag-hemorrhage ka. So, hindi umabot sa stage yung ako ganon because the swero did a lot. The third was the worst. Basta I had a fever, I passed out sa garden namin and I woke up 7 days later na. Parang pauwi na. Ang kwento sa akin was umabot daw fever ko about 39 to 40. Tapos yung hemorrhagic kind pa, the third, which was the worst. Naka-ready na sila sa blood. Diba? Because they thought I needed it. But I really don't know what happened in between those days.
Okay, so I would like to talk about the step or action that we can use to prevent dengue. Two main methods we can use to prevent dengue. First is reduce the mosquito habitat by get rid of their breeding, and the second method is avoid mosquito bite. Number one, in order to reduce the mosquito production, we can keep the rain gutters clean and free flow, so there is no place for the mosquito breeding. Second one is throw away the collected rainwater in our hot plates or trays. Besides that, we also can discard unwanted containers or junks that collect rainwater and keep the outdoor garbage bins covered. So for the second method, which is avoid mosquito bite, we can minimize our exposed skin by wearing a long sleeve clothing and long trousers to prevent the direct bite by the mosquitoes. Besides that, we also can apply insect repellent onto our skin to drive away the mosquito from biting us, since we are still under recovery phase from COVID-19. So most of us spend our free time at home. To restrain the mosquito from entering our house, we can keep the window closed where possible or install window screen. Okay, so next we move to the how government control dengue virus. For State Health Department, JKN is responsible for the implementation of dengue prevention and control activities to monitor and analyze the management dengue case at the state and district level. So there are several steps that JKN use to face this dengue virus, such as epidemiological surveillance. It acts as a center in dengue case management operations, which it will do continuous monitoring the dengue situation, identify which areas at risk of dengue, and give an important and latest information to the community through the social media. Other than that, they can also do collaboration with agencies such as coordinate meeting with community leaders and head of agencies or joint involvement in combating Aedes in area at risk of dengue outbreak. Okay, as for World Health Organization, their method to prevent and control dengue disease is similar to JKN. According to WHO, the main method to control or prevent the transmission of dengue virus is to combat the mosquito vectors by prevention of mosquito breeding and take personal protection from mosquito bites. Besides that, community engagement like educating the community on the risk of mosquito-borne disease was one of the suggested methods from WHO. Also, reactive vector control such as applying insecticides and space spraying during the outbreak. And last but not least, active mosquito and virus surveillance such as active monitoring and surveillance of vector abundance and species composition. Also, prospectively monitor prevalence of virus in the mosquito population with active screening of sentinel mosquito collection.
Dengue has distinct epidemiological patterns associated with the four serotype of the virus. It can both separate within a region, and indeed many countries are hyper-endemic for all four serotypes. Dengue has an alarming impact on both human health and the global and national economy. Then it is frequently transferred from one place to another by infected traveler when susceptible vectors of intent in these new areas. There is the potential for local transmission to be established. The numbers of dengue cases reported to WHO increased over 8-fold over the last 2 decades, from 500 and 5,430 cases in 2000 to over 2.4 million in 2010 and 5.2 million in 2019. Reported deaths between the years 2000 and 2015 increased from 916 to 4,032. The disease is now endemic in more than 100 countries in the WHO regions of Africa, the Americas, the Eastern Mediterranean, Southeast Asia, and the Western Pacific. The Americas, Southeast Asia, and Western Pacific region are the most seriously affected, with Asia representing 70% of the global burden of disease. Last year in Malaysia, dengue cases has been reported to increase about 29.4%, while the cumulative of deaths was decreased about 90% from the same period in 2019. In August 2021, dengue cases showed a decrease of between 20 to 94% in all states in Malaysia this year compared to last year, which is January to August 2021. The cumulative number of dengue fever cases reported was 16,565 cases compared to 63,988 cases for the same period in 2020. A reduction of 47,423 cases or 74.1%, and the average number of weekly dengue cases reported so far is 524 cases per week, compared to 1,700 cases a week in 2020 and 2,500 cases a week in 2009.